is a lens, okay, and this lens is bounded by two surfaces. When you will see it properly, you will see there is one this surface, and
Yes,
there is
sir.
one this surface, okay. So there are two
Yes.
surfaces bounded by two surfaces, okay. This lens is also bounded by two surfaces, okay. One surface is
Yes.
this, another surface is this, okay. So bounded by two surfaces, one of which must be spherical. So one of the surfaces must be spherical. What is the meaning of the spherical surface? Like concave or convex. Spherical means one of the surface must be concave or one of the surface must be convex. Okay. So what is a lens? A lens is a transparent medium bounded by bounded by two surfaces, one of which must be spherical. So these are the lenses. So generally in our syllabus we will discuss the thin lenses. In our syllabus we will discuss the thin lenses, and this lens is known as the convex lens.
Yes, sir.
Lens is known as the convex lens because this lens is bounded by two convex surfaces. So this is a bulging outward surface. This is a bulging outward surface.
Yes.
This surface is a bulging outward, and this surface is also a bulging outward. So that is why this lens is a convex lens. This lens is a convex lens.
Convex lens.
Huh. And this lens is
Concave.
bounded by two bulging inward surfaces. That is known. Bulging inward means concave surfaces. So that is why this lens is known as the concave surface. Concave surface. Concave lens. Sorry, not concave surface. Concave lens. So this is the concave lens. Now there is further classification of lenses. There are further we will classify these lenses. Basically, uh, uh, in case of the convex lenses, first lens is this. So this lens is bounded by two spherical surfaces. Okay, one spherical surface is this, another spherical surface is this, and the name of the spherical surface is convex surface. So this lens is bounded by two convex surfaces. So that is why this is also known as, either this is known as the convex lens, or we can also call it as biconvex lens.
Yes, sir.
Why we are saying it as biconvex lens? Because this is bounded by
Two convex
two convex surfaces. Yeah,
surfaces.
yeah, biconvex lens. Biconvex lens. Now you can see this lens. This is another version of the, or you can say modified, or you can say any word. Means this is another version of the convex lens. So here this is the plane surface and this is the convex surface. This is the plane surface and this is the convex surface. So this lens is bounded by two surfaces also, and one
Yes, sir.
surface in it is plane surface, another is the spherical surface,
Con
that is convex surface. So this lens is known as the plano-convex lens. Plano convex. Plano means we have taken the name from the plane surface. Plano convex. Plano
convex.
convex lens. Now see, this surface is the bulging inward, means concave. This surface is a concave surface, and this surface is a convex surface. So here this is the lens bounded by one concave surface, another convex surface. So this lens is known as the concavo convex. Concavo convex lens. Concavo convex lens. Okay, concavo convex lens. In the same way, we can classify the concave lens. So this lens is known as the biconcave lens because this is bounded by two concave
Two
surfaces.
concave surfaces.
Biconcave lens.
Yes, sir.
Biconcave lens. And this is one plane surface. This is one concave surface, bulging inward, concave. So this is known as the plano-concave lens. Plano-concave lens. Plano-concave lens. Plano-concave lens. Now see this now. This lens, this surface is a concave surface, and
Yes,
this
sir.
surface is a convex surface. And
Yes.
overall, this lens is a concave lens. Okay. One more thing I want to write here for the concave lens. For the concave lens, I want to write one more thing. Uh, concave lens is thick in the middle. In the middle, they are thick, thin at the ends.
Yes,
So
sir.
thick at the middle. Thick at middle. But on the other hand, concave lens are thin at the middle, thick at the edges.
Middle and thick at the end. Ends.
Thick at the edges. Thick at edges. Okay. So now you can see this lens is thick in the middle. So overall nature of this lens will be convex lens. This lens is also thick in the middle. This lens also is thick in the middle. Now this lens is thin in the middle. This lens is thin in the middle. Thick at the edges. Thick at the edges. This is also thick at the edges. So basically, this is a concave surface, bulging inward. This is a convex surface. So this overall
Yes, sir.
name of this lens is convexo-concave. Convexo-concave lens. Convexo-concave lens.
Concave lens.
So these are some of the classification, and there is a requirement of mostly this lens and this lens and this lens, and um you can say sometimes maybe this lens also. So you
Yes,
should
sir.
know what are the types, okay? Because there is a requirement of that, okay? There is a requirement of. Okay, so first just copy this. First understand means what are the lenses and what are the types of the lenses. Okay, then we will discuss the
Yes.
center of curvature, radius of curvature, focus and focal length of these lenses. Okay, like mirrors, they also have the focal length, center of curvature, radius of curvature.
So let's hold on.
Okay.
So scroll down. Done, sir.
Okay. Now we will discuss the center and the radius of curvature. Center of curvature and the radius of curvature. So now you can see here, this is a convex lens, and for this convex lens, there is one spherical surface. There is one spherical convex surface, and for this convex surface, the radius of curvature will be here. Means the center of curvature will be here for this surface. For this first surface, this is the first surface, and this is the second surface. And for this second surface, the center of curvature will be here. Okay. Now, this distance is the radius of curvature. Means distance from here to here. This distance will be r1, and this distance from here to here will be r2. So C1 is the center of curvature, R1 is the radius of curvature. Okay, and this is C2. And the line joining between C1 and C2 is known as the principal axis. Now for the concave lens, for this spherical surface, suppose the center of curvature C1 is there. This is for first surface, and this is for the second surface. So
Sir,
this
you're
is the
lagging,
first.
sir.
My voice lagging.
Yeah. Second, continue, sir.
Okay, just a minute. Checking. Okay. So for this surface, first surface, this is the center of curvature C1. For the second surface, the center of curvature is C2. This is C2. And now for the radius of curvature, this distance will be the radius of curvature. That is R1. And this distance, you can take the radius of curvature R2. This distance. The radius of curvature R2. And what is principal axis? Principal axis is the line joining C1 and C2. This is the principal axis.
Yes, sir.
line joining C1 and C2. And what is C? C is the center of curvature. What is R? R is the radius of curvature. Okay. So this is the center of curvature and radius of curvature. Okay. So now you can note down.
Done, sir.
We will discuss optical center. So what is optical center? Optical center is a point on the principal axis. Is a point on the principal axis. Okay. When a light ray passes through it, it will remain undeviated. For example, this is a convex lens. This is a convex lens, and you take a ray of light. So I'm taking a yellow light, and if this is passing from some specific point, it will not deviate it. So this point is the optical center. This point is the optical
Center.
center. Now, in case of the concave lens, in case of the concave lens, same concept will be used when a optical center is a point from which when a light ray passes, there will be no deviation of the light ray. So this is the optical center. Optical center. Now you can read. What is the optical center? Optical center,
Pointer
a
on a
point on the principal
principal
axis
axis of a lens through
of a lens
which a
through
ray
which
of light passes
light
through
passes
undeviated.
through, passes undeviated. So you can say this is a point through which the light rays passes undeviated, and this point is lying on the principal axis. This is the principal axis. This is the principal axis. Now we will discuss the focus, focal length, and the focal plane. So first we will discuss the first focus of a convex lens. So in case of mirror, there is only one focus, but in case of the lenses, there are two focuses. Foci, F-O-C-I-I. Foci is the plural of focus.
Yes, sir.
First we will discuss for the convex lens. So this is a convex lens. So first focus for the convex lens is, you can say, if you are placing an object, for example, this is the first focus. Okay. And if from this focus, the light ray is going like this, striking on the lens like this, striking on the lens like this. And after passing from the lens, the light rays are becoming parallel. The light rays are becoming parallel to the principal axis. Then the given point is known as the focus, first focus. Okay. So if a light ray is like this, and after passing from the lens becomes parallel, if you are placing the object here, and after light rays from that object, after passing through the lens, becomes parallel to the principal axis, means that point that you have, where you have placed the object, is the first focus of the
Focus,
lens.
yes.
First focus for the convex lens. Now for the concave lens, the concept is different. So okay, suppose these are the rays of light. These are the rays of light. Okay.
Yes,
And this
sir.
ray of light is going towards a point, and there is another ray of light this is also going towards a point, and after refraction, these rays are becoming parallel to the principal axis. After refraction, these rays are becoming parallel to the principal axis. Okay, now see. So this will be the first focus in case of the concave lens. First focus in case of the concave lens. Now you can just define the first focus as whenever light ray is going towards the first focus, after striking from the lens, become parallel to the principal axis. So this
Yes,
is the
sir.
first focus. Now we will discuss the second focus and the principal focus. We will discuss the second focus, and for us, second focus is more important than the first focus. Generally, we will talk about the first focus only. So second focus only. So what is the second focus? So second focus is defined as whenever rays of light are coming from the infinity. Whenever rays of light are coming from infinity. And we know
Yes, sir.
that from infinity, always the parallel light rays are coming from infinity, like from the sun. Sun is, we consider sun at an infinite distance.
Yes, sir.
So whenever rays of light are coming parallel to the principal axis, after striking from the lens, meeting at a common point. After striking from the lens, meeting at a common point.
On point.
Suppose all the light rays are getting converged and meeting at a common point on the principal axis. So basically this is the point on the principal axis. Okay, this is known as the second focus or the principal focus.
Yes, sir.
Second focus and
Or the
the
principal.
principal focus. So whenever the light rays coming parallel to the principal axis after passing from the lens, converge at a point, and that point is known as the second focus or the principal focus of the convex lens. Now, in
Yes,
case of
sir.
the concave lens, now what is the concept for the concave lens? For the concave lens, the concept is little bit different because remember, always remember, convex lens is a converging lens. So you can see light rays are getting converged here, but the concave lens are the diverging lens. Concave lens are the
Other diverging lens.
concave lens is a diverging lens and convex lens is a converging lens. Okay. Now another, for the concave lens, we will define the second focus. So whenever the light rays are coming parallel to the principal axis, suppose the light rays are coming parallel to the principal axis, and these light rays will get converged like this, and you have produced these light rays backward direction. Okay. Another light rays like this. Light rays like this, and this light ray is getting converged like this. Oh, diverged like this, and we have produced this. Okay. Now you can see. Uh, hmm. These light rays are parallel to the principal axis.
Yes, sir.
After striking from the lens, getting converged, and when you will producing these converged rays in the backward direction, meeting at some point, and this point is known as the second focus. This point is known as the second focus of the concave lens. Second focus of the concave lens. Second focus. F2 means second focus. F2 means second focus. F1 means first focus. F1 means first focus. And I told you that second focus is more important for us than the uh, first focus. Okay. So remember, always remember second focus. I am
Yes,
not
sir.
saying do not remember the first focus, but most important is the second focus or principal focus. Okay. So principal focus. Okay. So now you can note down all these points. And also remember, this optical center is also very important point because most of the image formation we will do with the help of this concept. Done?
So just a minute.
Okay, okay.
Done, sir.
Okay.
Done, sir.
Okay. Done.
Yes, sir. Done.
Okay.
Can scroll down.
So now these dotted lines are representing, we are just producing these incident rays. Okay. So these dotted lines I have drawn with a purpose,
Yes, sir.
because these are not actual lines. These are not actual light ray. This is just representing. We are just extending, or you can say, we are just producing by ourselves. When completed, ask me to scroll down. Okay.
Done, sir.
Okay. Very good. This thing I think you have studied in 10th class also. For the convex lens, the convex lens is a converging lens, and the light rays from the parallel meet at a point that is known as focus after conversion.
Yes, sir.
Hmm. Scroll down.
So just a minute, sir. Just a minute.
Okay, okay, no problem. No problem. Fine.
Done, sir. Can you scroll down?
Okay.
Done, sir.
Okay. So now we will discuss the focal plane. We will discuss the focal plane for the concave and the convex lens. Focal plane. Focal plane. Okay. So first I will discuss with the I will discuss focal plane of the concave convex lens. So for the convex lens, so this is a convex lens, and
Yes, sir.
suppose this line is a principal axis. This line is a principal axis, and there are some light rays which are parallel to itself and striking on the lens. There are some parallel light rays, and these light rays are parallel to itself, not to the principal axis. This time, these light rays are not parallel to the principal axis, but these light rays are parallel to itself. So what will
It's
happen after converging from the lens, these light rays will meet at a certain point. After converging from the lens, these light rays will meet at a certain
yes,
point.
sir.
Suppose here these light rays are meeting after converging from this lens. So this point will lie on the focal plane. This point will lie on the focal plane. So focal plane is a plane whenever light rays parallel to the lens meeting at a common point, and that common point is lying on the focal plane.
Yes, sir.
So this is the focal plane. Focal plane. Okay. Now for the concave lens. This is a concave lens, and suppose the light and one more thing, we know that convex lens is a converging lens, but concave lens is a diverging lens. So first we will draw the principal axis.
Yes, sir.
So this is the principal axis, suppose. This is the principal axis. And suppose the light rays are also parallel to this, means parallel to itself, but striking on the lens
Yes,
like
sir.
this. Now, this lens is a diverging lens. This lens is a diverging lens. So what this lens will do? This lens will diverge these parallel rays. Diverge these parallel rays, and these parallel rays will meet at some point. Will meet at some,
Some.
appearing to meet at some point. So these rays are getting diverged, and incident ray. These are the incident ray. And when you are producing these rays in the back, these diverging rays in the backward direction, so you are getting. Okay, now you can see these are the parallel rays, These are the parallel rays parallel to itself, not parallel to the principal axis. After
Yes, sir.
diverging from the lens, if you are producing these diverging rays in backward direction, then they will appear to meet at a common point. Here, they will not. These rays will not meet here. Actually, these rays will meet somewhere. Okay, I'm drawing again it. So again, I am drawing. These are the parallel rays. These are the parallel rays, and getting diverged and producing backward. Okay. Okay. Now another ray meeting at this point, getting diverged, producing backward. So now these are the parallel light rays, and these parallel light rays are striking on the lens. After striking on the lens, after passing from the lens, these rays will get divert. These rays are diverging. Okay, these rays are getting diverged, and when these diverging rays you are producing in the backward direction, meeting at a common point, and this common point is lying on the focal plane. Common point is lying on the focal plane. Okay, so you
Yes,
can
sir.
say. This is the focal plane. Okay, write down here. Write down here focal plane. Focal plane for convex lens. This is the focal plane for
Convex
concave
lens.
lens.
Concave.
Concave lens.
Yeah, concave.
Harsh, what is this white color line showing? This line?
Principal axis.
Yeah, very good. Principal axis.
So you're gonna scroll down. Sir,
Hmm.
can you scroll down?
Yeah, of course. Then we will discuss the focal length of convex and the concave lens.
Done, sir.
Okay. So focal length. This is a convex lens, and these are the rays, and this is the focus. F2 is the principal focus, and here if I am taking as the optical center, C is the you can take optical center as O. O is the optical center. O is the optical center. So the distance between the optical center and focus is known as the distance between the optical center and the focus is known as the focal length. So you can say this distance will be the focal length.
Yes, sir.
Focal length. And one more thing, we will use the sign convention here. We will use the sign convention here. We know that in case of mirror, I told you all the distances we will measure from the pole. In case of mirrors, we measure all the distances from the pole. In the same way, in case of lenses, okay, in case of lenses, we will measure all the distances from the optical center. Okay, and one more thing, the direction measured, I told you many times, the direction measured in the incident light direction will be positive.
Yes,
So
sir.
incident light is in this direction. So means this direction will be considered as positive direction. So this F2 will be positive or negative?
Can you repeat, sir?
I'm saying that I told you what is the positive direction for measuring distance? Direction of incident light.
Yes, sir.
So I am saying that all the distances we will measure from the optical center.
Yes.
Okay. Now
Yeah.
I am saying if I am calculating this F2, whether I will take this F2 positive or negative?
Positive.
Positive, because I am measuring F2 from optical center to F2. That will
Yes,
be
sir.
positive. Okay. Now for the concave lens. So focal length, you can write 1 point for focal length. The distance between the optical center, the distance between optical center and focus. Simple. And focus. Now for the concave lens. So for the concave lens, the focus is on the left hand side. And if this is the optical center you are taking, so you will measure the distance like this. You will measure the distance from the optical center to the focus like this. So this will be your F2. So now
Yes,
tell
sir.
me, Harsh, will you take this F2 positive or negative?
Negative.
Negative. Why? Because we are measuring this distance in the opposite direction of
Opposite
the
direction to the rays.
incident ray. So this
Yes.
direction is positive here, and this direction you will consider negative here, because this direction is in the direction of the incident ray. This direction is in the opposite direction of the incident ray. Okay, so please write down this focal length. This focal length is also very important point.
Okay, sir.
Again and again we will use focal length, focal length.
Second, scroll down. Done, sir.
Okay. So now we will discuss the rules for the image formation by the convex lens. Earlier also we discussed this topic in case of the mirror, rules for the image formation by the concave and the convex mirror. For this time, this is the lens. So first rule, uh, if a ray of light is parallel to the principal axis, if a ray of light is parallel to the principal axis, after passing through the lens, it will pass from the focus. Understanding? If a ray of light is parallel to the Harsh,
Yes,
are you
sir.
listening me na properly?
Yes, sir. Yes, sir. Yes, sir. Yes,
I'm
sir.
taking
Yes. A ray of light.
A ray of light is parallel to the principal axis after passing from the lens becomes parallel will pass from the focus. Okay.
Focus.
Okay.
Yes.
Now next rule. Suppose here is the first focus f1, and if a ray of light is passing from the first focus and striking on the mirror, and after passing from the mirror becomes parallel to the principal axis. Second rule. Now third rule. Third rule is very simple, you already know. Whenever a ray of light is passing from the optical center, it will pass straight. O is the optical center. O here is the optical center. And what does white color line represent?
Principal axis.
Principal axis. Okay. Okay. Write down. And we will use this rule, rule number 1, and
Yes.
rule number 3 to form means for the for drawing the ray diagram for the image formation by the convex lens. Okay, so we will use mostly rule number, not mostly, all the time we will use rule number 1 and the rule number 3rd, not the rule number
Okay.
3.
Okay, sir.
But you should know this. Okay. Write down.
So can I write from rule number 1?
Okay,
Can I
okay.
write from rule number 1?
Just. Okay, of course. Sorry.
Done, sir. Can you scroll?
Okay.
Sir, can you scroll down? Done, sir.
Okay. So now we will discuss the image formation by the image formation by the convex lens.
Yes, sir.
So this is a convex lens, this is the principal axis, and suppose there is an object placed here, and first we will mark what is focus and all that things. This is the f1, and this is the this is 2f1, and this is f2, and this is 2f2. Okay. So I am just placing the object beyond the center of beyond 2f1. Here I am placing the object. This is the object behind 2f1, and remember this is the optical center. This point is the optical center. Okay, and this is f1 means the first focus, this is the second focus. And what is 2f2? 2f2 means the distance between the optical center and focus is same as that of f2 and 2f2. Same
Yes,
is the
sir.
case with f1 and 2f1. Now from
Yes.
For drawing the ray diagram, there is a requirement of two rays from the object. This is the object. There is a requirement of two rays from the object, so we will draw two rays from the object like this. First ray from the object is like this, parallel to the principal axis, and we know that whenever a ray of light is parallel to the principal axis, it will pass from the focus like this. Okay, will pass from the focus like this. Now another ray from the light is passing from the optical center and pass straight, no problem, na? So
Yes,
both
sir.
the rays are meeting here, means here your image will form. Here your image is
Image will form.
Here at this point. At this point your image is formed. So this is your image and this is your object. Now see, means you can see the rays are actually meeting or
Yes,
appearing
sir.
to meeting. Actually meeting, na?
Yes, sir. They're actually meeting.
Actually meeting means the image is real. And you
Real.
can see, and inverted
Inverted.
also. See, inverted.
Real and inverted.
And what about the size of the image? Less than the object.
Less than the object.
And what is the position between f2 and 2f2?
Between f2 and 2f2.
Yeah. So we will write the characteristics of image. Image is number 1, formed between f2 and 2f2. Formed between f2 and 2f2. Number second, real and inverted. Number third, larger than smaller than object. What is the other name of smaller than object? Diminished.
Diminished.
Yeah. Diminished. Now another case I am taking. I am
Sir,
placing
just a minute, I'm noting this down.
Oh, first you will write down. Okay.
Yeah.
No problem. Okay,
Because
so
then
I'm
after I'll
writing.
have to draw everything.
Okay, no problem. Actually, na, I'm writing this is the case number first when object is beyond 2f1. Now you can write.
Done so.
Okay, now we will discuss another case. We will place this object, this object, this object here at 2f1. Okay. 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 So this is. Now we'll place the object at 2f1 here. This is the object at 2f1. Now from this object, for the ray diagram, there is a requirement of two ray. First ray is like this, parallel to the principal axis, and whenever a ray of light is parallel to the principal axis, it will pass from the focus. Okay. And another ray of light from the object is passing from the optical center. Okay. So here the image will form at this point. So where the image is forming this time? Can you tell me? At 2f2.
At
At 2f2.
2, yeah, at 2f2.
2f2.
It is real and inverted.
Real and inverted. And can you what can you say about the size this time?
It's same.
It's same. Okay. So image is number 1 formed at 2f2. Number 2, real and inverted because rays are actually meeting.
Yes,
And
sir.
it is inverted. You can see the direction of arrow. Real and inverted means direction of arrow means above principal. This is above principal axis. This is below principal axis. That is why image is, this is the object, this is the image is below principal axis. That is why this
Yes,
is
sir.
inverted image. So real and inverted. Do you know there is one lens in our eye?
Yeah.
Which type of lens is this? Concave or convex?
Convex.
Yeah, very good. So what type of image formed on retina? Do you know what is retina?
Yeah, it's
So what type of image formed on retina of any object you are watching? Means suppose you are just watching this screen that I am
yeah.
teaching image, this text screen,
Yeah.
text on the screen. Then what type of image is formed on retina this time? Inverted or erect?
Erect.
No, no, no. It is forming inverted image. Then you will say, sir, if the image is inverted, then how I will see? I am watching all the things erect. Means okay. Then actually now what happens on retina, image is formed real and inverted always. But due
Okay.
to the actually there is one there on retina there are some light sensitive cells actually I think named rod and cones. So
Yeah.
when
For bright lights, the rods or something.
yeah. So actually now when image forms, so what happens now there? When the inverted image forms, so these cells get activated, and there is an optical nerve. There is an optical nerve. Have you heard about the optical fiber? So
Yes, sir.
what is the use of the
So
optical fiber?
that sends signals very fast.
To send the signal very very fast, or
Yeah.
like in the optical fiber is a connection between the eye and the brain. So
Yes, sir.
now those rods and cones converted the image into the electrical signals, and those electrical signals are passed through the optical nerve through to the brain.
Yes,
Now
sir.
the brain is responsible to form the erect image.
Okay.
Okay. That is happening actually.
Sir,
Same.
acha, acha, yeah.
Uh,
No,
actually,
no, I
no.
was asking what is SAM? You wrote SAM first. I was like,
Okay, Sam. Actually, that is not Sam. Same size of same size
yes,
as object. Okay.
object, yeah.
So, do you have maths or bio?
Bio.
So you should know these things very clearly, I think.
Yeah, I know that, but I didn't know the thing.
Okay.
Real. I knew it was real and inverted, but
Yeah.
how do we see it? I didn't know that.
Okay. So this is the object at 2f1. 2f1. Okay. Now you can copy this also. We are using only two rules, you can say. One, parallel
Yeah.
light ray. Okay, if there is a parallel light ray.
And when passing
then
through the optical center.
no, it will pass from the focus. And if a light ray is
No,
passing
the
from the,
second one.
and another is the, when the second one is passing from the optical center, it will not get deviated. Now you can see this is not getting deviated, going straight.
Yes.
So only two rules we will use to draw the ray diagram.
So done, sir.
Okay, another case we can just see. So this time we will place the object here. Object is here, no, we will place the object between two f1 and f1. We will place the
Yeah.
object between two f1 and f1.
Image will be formed beyond the 2f, right?
You are right. So now I am placing the object here. This is the object. Now again, two rays from the object will be there. First ray is parallel to the principal axis. After refraction, it will pass from the focus. Another ray from the object. Okay, like this.
Yeah, it will form beyond 2f.
Yeah, forming here somewhere. So it is forming beyond 2f2 and beyond 2f2 at the same time beyond 2f2 and one more thing, larger than the object also. Image, this is the image larger than the object and real and inverted also, because rays are actually
Yes.
meeting, and below principal axis means real and inverted. So you
Yes,
can say
sir.
image is number one formed beyond 2f2, formed
Beyond 2f2.
beyond 2f2. Number second, uh, real and inverted,
Yes.
real and inverted, and last is the larger than object. And what is the other name of larger than object? Magnified.
Yeah. Magnified. Yeah, magnified.
Yeah, magnified. Not amplification is different thing. We will study the amplification also. Magnified. Okay, write down. So you can notice one more thing here. See here, just a minute. As the object is approaching towards the lens, approaching towards the focus. Okay, initially where is the object? Beyond center of curvature, and where was the image? Image is between 2 and f1.
Yes,
Now
sir.
object is here. Now image is shifted on the left side. Means you are shifting the object on the right side. Image is also shifting on the right side. You can see.
Yes, sir.
Image is shifting also on the right side. If you are
Right
shifting
side.
the object. So case number
3.
third. Object between f1 and 2f1. Okay, right.
Done, sir.
Okay. Case number 4. So we will place now the object at f1. Again, we have shifted the object to the right. At f1 we will place the object, and again two rays from the object will be there like this. First ray is parallel to the principal axis. Before that, first ray from the object is parallel to the principal axis. It will pass from the focus like this. Another ray from the object is passing from the optical center. Now you can say both the rays are parallel.
Yes, sir.
Both the rays are parallel, and where the parallel rays meet at infinity.
Infinity.
Yeah, so means here the image will formed at infinity, and image will be very, very large as compared to the
Yes, sir.
object. So parallel rays meet at infinity. So you can say image is number one, formed at infinity, formed at infinity. Number second, real and inverted also.
Yes, sir.
Real and inverted. And number third, highly magnified or much larger than optic.